Chapter 1 is on electrochemistry. So we kind of return to thinking about chemical reactions, and we have to think back to some things we learned in Gen Chem 1 in Chapter 4 about what happens when substances transfer electrons, and that's what redox chemistry really is. So we do a good bit of review to make sure that we understand the terminology involved in redox reactions before we actually move into thinking about how we actually do chemistry with it. 5 skills for this chapter again. The first is thinking about how to balance redox equations. And so this is a little bit different than we learned in Gen Chem 1 when we used oxidation states to balance equations. This is actually going to be using a different formalism, and then we'll learn methods for balancing in acid and base solutions. So kind of some nitty-gritty things to think about with balancing redox equations. We move then into 2 skills. The next 2 skills are related. They're thinking about Voltaic cells. So the first skill is thinking about how we diagram a voltaic cell. And so a voltaic or a galvanic cell is really just separating the redox reactions that occur. So again, we're going to have an oxidation and a reduction reaction, separating them into 2 compartments and allowing the electrons to travel through a wire. And then we can use that energy of the electron travel through wire to do work. And so that's how a battery is created. So we do a lot of work thinking about how to qualitatively diagram a voltaic cell, and then in the next skill we think about how to actually quantitatively determine just how much power would be in that battery based on the differences in standard reduction potentials that we have between the 2 different species. And so that's where Appendix D comes in, and being able to really utilize the values in that to predict what the E for a reaction is. The 4th skill that we have in this chapter is really thinking about how to relate some of the previous concepts that we've had that deal with energy, like thermodynamics and equilibrium, and how they kind of tie into this E cell, this standard reduction potential that we have for cells. And so we learn, like we had for going around the block with pH and pOH and so forth, we have now a triangle, and we've got 3 equations to relate free energy as in delta G, equilibrium constants with K, and then E for our standard reduction potential. So we learn how those all 3 sort of come together. And then the very last part of our chapter is dealing with the Nernst equation. And we really didn't deal with non-standard conditions in our thermodynamics chapter in chapter 20, but we do want to consider non-standard conditions with our electrochemistry chapter, because sometimes it's those non-standard conditions are what powers our batteries. And this is important from a biochemical standpoint, because having those differences in concentration is really how you power so many of the little batteries that are in your cells, by having concentration gradients. So we learn about the Nernst equation and how to apply that to thinking about the energetic driving force for redox reactions, whether it's in an actual battery or it's in kind of the batteries of your cells. So an interesting chapter to kind of conclude here with electrochemistry.